Hi students, let's look at this question here which was taken from the year 2016 ACJC mid-year. Question 4, this question is on parametric equation. Let's see how I can do this proficiently. So the curve C has a parametric equation of x equals to 3. So this is x equals to 3 minus 2 cosine t. Then y equals to negative tangent t, right? So what you need to do is actually for this expression here 0 to pi over 2, using differentiation, show that C does not have any stationary point. So if you want to show that C doesn't have any stationary point, what you need to do is actually dy dx. dy dx cannot be equal to 0. Okay, so this case here, we're going to put that dx dt will just be negative 2 negative sine t, and dy dt will just be negative secant square t. Okay, so dy dx on the other hand, dy dx will just be dy dt over dx dt, right? Which is positive. So this case here, if I were to rearrange this, it will be 1 over 2 sine t cosine square t. Alright, so this expression here, obviously, since this one cannot be equal to 0, because top is 1. Equals to 0 meaning top has to be 0, right? But because denominator, you can't let it be 0, it is not going to 0. So since dy dx cannot be equal to 0, hence C doesn't have any stationary point. Yes, that's okay. Okay, then for part 2, let's look at part 2. A point Q has this parameter t pi over 2. Find the equation of tangent Q, leaving your answer in exact form. Okay, great. So at t equals to pi over 6, right? What we need is actually x. We need to find x equals to 3 minus 2 cosine pi over 6. This is exact form. So how do we find exact form? This is cosine 30. So cosine 30 is actually root 3 over 2. Okay, I mean cosine 30 are root 3 over 2. So this is root 3 over 2, and this will just give us 3 minus root 3. Now if you've forgotten that this is exact form, you can actually use your GC to find. So what you can do is actually just make sure it's in radian mode, then you just use cosine pi over 6. Alright, then this is a gibberish. You can either remember this as root 3 over 2 or just square this, and this is actually pi over 6. This is 3 over 4. So square root 3 over 4 is root 3 over 2. Okay, that's good. So then y will just be negative tangent pi over 6. So 30, tangent 30 will be 1 over root 3. Okay, so this is negative 1 over root 3. Okay, so tangent 30 degrees, so pi over 6 will be 1 over root 3. Okay, so that's how you see that. So this done already, and you know that dy dx is a gradient of tangent, which will be negative 1 over 2 sine pi over 6 and cosine pi over 6 square. Okay, sine pi over 6 will be half, then this will be root 3 over 2, 60 square root, then this will just be 1 over 3 quarter, and this will be negative 4 over 3. Okay, so hence equation of tangent, let me just write this at the side because this is like that. Okay, equation of tangent will be equation of tangent. Okay, we're going to use y minus y1 equals to mx minus x1. Equation of line, that will be y minus 1 over 3 equals to negative 4 over 3, x minus 3 minus, and that will give us negative 1 4 over 3 x, and that will be, this will be y plus 4 over 3. This is minus 1 over root 3. 1 over root 3 is 1/3 root 3. The reason why I'm changing to root 3 is because there's a root 3 here. You can simplify this. And what we'll get is actually very quickly, this case here will just be negative 4 over root 3 plus 4 minus 4 root 3, 4 3 root 3 minus 1/3 root 3. So this is like negative 1/3 and negative 1/3. You add it will be negative 5 over 3, right? So it will be 1 over negative 4 over 3x minus 5 over 3 root 3. That's equation of tangent. There you go. So that's how you do the first part.